Okay, we've seen how we can calculate values using function notation, and we can do it off a graph as well. If they ask you for something like f of 5, they're saying, what does the function give you when x is 5? What we've been doing in the past is taking our function, and everywhere it had an x in it, we plug in the number 5. What you can do instead, if you have a sketch of the function f, is you can say, okay, when x is 5, 1, 2, 3, 4, 5, where is my function? It's down here, and its value is -2. This is just saying when x is 5, what's y? This says when x is -2, down 2, function's up here, so we get a value of 3. And when x is 4, 1, 2, 3, 4, y is, what is that, -1? One step down. Pretty simple as long as you have a graph and it's on a grid so that it's easy to read. Write the ordered pairs for what we just did. The first one was x was 5 and y was -2. The next one was x was -2 and y was 3. And when x was 4, our function was at -1. State the values of x if, now we're working backwards. This is the thing where they say, we've got our function, we put in an x, but we're not telling you what it is, and the result was -1. So here's -1. If the function is here, what's x? Function seems to be right about there, so what's our x? Looks like 4 to me. They give us the y, so you start at y equals -1, find the function, and see what x value it has. We would say if f of x is -1, then x must have been 4. Now something a little weird is going to happen. If f of x is 3, 1, 2, 3, here's the function, and here's the function again. Two possible values. X could be 2, or x could be -2. You can say x equals -2, 2, or if you want to be compact, you can use that trick we learned from the roots and say x is ± 2. If f of x is 4, the same thing happens. If y is 4, we're up here, and the function could be -1 or 1. I'll write it the compact way and say x is ± 1. Use the notation in A to make a statement about the points. Notation in A as in function notation to make a statement about the points A and B on the graph. What are the coordinates of this point? It's 1, 2, 3, 4, 5 to the left and 1 up. So they're talking about the point -5, 1. In function notation, you'd write that f of -5 equals 1, meaning this is the x value that goes in, this is the y value that comes out. Do that for B. What are its coordinates? 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3 down, so -3. There's our point. In function notation, you'd say, I took function f, I gave it 6, and what it spit back at me was -3. Write the x and y intercepts. Where are the x and y intercepts? Here's an x-intercept. Here's a y-intercept where it hits the y-axis, and it's got another x-intercept over here. So 3 different points we have to worry about. The first one is -6, 0. The peak here is 0, 5. And the right-hand x-intercept is, that's 3, isn't it? 3, 0. So in function notation, these would be f of -6 equals 0. I'm sorry. I said it correctly, I didn't write it correctly. F of -6 equals 0. This one would be f of 0 equals 5. I gave it an x of 0, and 5 is what it gave back. And this one would be f of 3 equals equals 0. Complete the following statements. The domain of the function is, how far does this thing go? There are no arrowheads on it, so it really does have beginnings and ends. In the x direction, it begins at -6 and makes it all the way up to, what is that, 5, 6? Looks like 7 is where it cuts out. Goes from -6 to 7. So for our domain, we could say the lower bound is -6, the upper bound is 7, and they gave the XER for us. Vertically, where are the top and bottom of this? This is the lowest it ever gets, which seems to be -4, eh? And the peak is up here at 5. So measuring vertically, it goes from -4 to 5, which makes the range -4, less than or equal to, and less than or equal to 5. Notice they're putting f of x instead of y here, but we've seen already that these are interchangeable, so that's no big deal. This is your horizontal limits, the left wall and the right wall, and this is your vertical limits, the floor and the ceiling.